Hello everyone, and welcome to the first data science lesson. Today we'll be giving an overview of what data science is about, and then we'll jump straight in to talk about databases. Here are some of the things that we hope that you will learn from today's lesson. We want to give an idea about how the big data has arisen recently from rapid development of new technologies and increased connectivity through the internet. With all that data you and I are generating, this has led to opportunities to analyze that data to optimize our quality of life and to inform decision making. This is what is the crux of data science. But with that much data being generated, it becomes imperative to come up with a way to organize all the data, and that's how the theory of databases comes about. So the essential question that we want to answer for today is, how can this raw data be organized into databases so that we can have that efficient analysis that we know as data science? So first, let us lay down some groundwork by defining some of these terms. Some of these terms in the data science and machine learning AI world are sometimes used interchangeably, so we want to make these definitions clear to you at first. So data science is defined as it is a set of fundamental principles that support and guide the principal extraction of information and knowledge from data. So we are working with data and we want to analyze it and be able to find out more about the data. So data science has practical applications of machine learning. It's a practical application of machine learning with a complete focus on solving real world problems. It is also important when you do data science to have a grasp of the subject matter in order to understand the problem and the data better so that you can make proper judgments from it. Artificial intelligence is an adjacent field that focuses on making intelligent machines by reproducing human intelligence through learning, reasoning, and self-correction or adaptation. Recent efforts in artificial intelligence focus on using the data that humans have generated in order to teach robots or teach machines to mimic that data or mimic those patterns they find in the data in order to mimic that intelligence of humans. And this approach towards data science is what we call machine learning. So machine learning is the computer science field of studying of allowing algorithms to improve through experience. Okay, when I say experience here, the experience can either mean more data that humans have generated, or sometimes machines can even learn from its own mistakes and successes. We'll talk a lot more about machine learning in the future weeks, but today we just want to focus on data science and in particular the organization of the data in order to feed this data to a machine, a computer, so that the machine can learn these patterns and mimic or mimic that data, mimic that patterns, or as well as make decisions from the patterns. So this is a Venn diagram that is quite famous when it comes to data science. So when you do data science, you need to know a little bit of computer science because you need the computers and the programming skills to analyze that data. You also need to have math and stat skills because we are extracting patterns, right, from the data. So statistics is needed in order to summarize the data or to help to create visualizations, graphs for the data. when you do data science, you also need to have some domain knowledge so that you are able to put that data, put that predictions into context of the domain or the business that you need to make these decisions for. I like this definition that was presented at a TED Talk. A data scientist is a unicorn that bridges math, algorithms, experimental data, experimental design, engineering chops, communication, and management skills. The way they would use the word unicorn alludes to the idea that a data scientist is expected to know a lot of things. The good thing is that if you're interested in data science, the good thing is that you don't have to be an expert in all of that. You just need to know a little bit in order to combine them and in order to synergize information from that interdisciplinary knowledge that you have. So a little bit more about data science and machine learning. If you're interested in a job in this area, you may be interested to know that different people or different jobs require you to specialize in different bits of knowledge. In SST, we're going to focus on the data analysis, data scientist role, and a bit of the machine learning engineer's role in our data science and machine learning module. So I hope you have an idea of what data science is about and why this field is getting more and more hot and more exciting these days due to the amount of data we are generating when we use our mobile phones, when we use our smart devices, when we use our Internet of Things devices. We are actually generating a lot of data that can be analyzed in order to improve our lives as well as to predict what may happen in the future or predict how you would behave in certain situations. So now we go on to talk about how we can organize this data. Organize this data into a meaningful way so that analysis becomes smooth and easy. This way that many data scientists use is called relational databases. So, what is a relational database? It is a standard way of representing data using tables so that it can be used by any application. This organization should allow for adding, modifying, and querying or retrieving data easily. Sometimes we have data that's more complicated, and when that happens, we want to use more than one table that are related to each other in order to organize that data. I'll give you an example in a short while. So some of the applications of the use of relational databases, actually practically anything that needs to store data for analysis will use a relational database. Or anything that's not a video or a photo bank will require some kind of relational database. We can use it to track inventories. So if you own a store, you may want to know how much goods you have sold so far. Or if you own an e-commerce store or a Shopee shop, Lazada shop, the database can help process your e-commerce transactions and as well as manage your inventory as well, right? If you're a company that deals with a lot of customer information, for example, Netflix may want to keep track of all the customers they have and what kind of patterns of viewership they have, what kind of shows they like to watch, how many hours do they watch, when are their most common view times. So all this can be stored in a relational database to be analyzed and in order to make good predictions or recommendations of shows that these customers may like. So recall that we have talked about these things before, data fields and data records. These are the things that we have already talked about in your spreadsheets chapter. So if you recall, a field is actually a column of data in the spreadsheet, and your column heading or your field name is the description of data stored in a particular column or field. A record is just simply a data point in your data, okay? A set of related data that describes a person or a thing, usually a row in the spreadsheet. So an example on the right, name and additional family members, these are fields in your database, in your spreadsheet, and each person represents a record. Now, let us extend that understanding of a spreadsheet or data stored in a spreadsheet into a more formal idea of databases. Okay. Some of the terminology that's popular or important to know in a database is the idea of a primary key. So a primary key uniquely identifies a row in a table, just like in the previous slide we saw how the person's name can uniquely identify that data and everything about that person. So no two rows should share the same primary key, otherwise it will be very confusing. Am I talking about student, which Farhan am I talking about, right? Or which Alex am I talking about, if there are two people with the same name? So an idea to go deeper into that idea, it is possible to have two students with the same first name in a class, but they will have different index numbers. Related to that is what we call a foreign key. So a foreign key references rows in another related table. For each value of a foreign key column, there should be a row with the same value in the corresponding primary key column in the other table. I'll give you an idea of how that works in a while, okay, because I know it's very wordy here. Okay, so you just need to know that the foreign key serves as a link between tables, okay, and I'll show you how that link happens in a short while. Okay, so an example of this foreign key is that sometimes when I have a class list of students, I may also write down the form teacher's name for every student, so that I know I can easily access who the form teacher is for every student, right? So, but the form teacher's name may link to another table of teachers, with more information such as the subject they teach, their email address, perhaps, or even more information about them. So here's a business example. Here I have 3 tables, one named customers, one named product, and the other is orders. So remember, our primary key is supposed to uniquely identify the record, right? So can you identify the primary key for each table? And secondly, the foreign key is supposed to link into more data about that item in another table. So the only table here with foreign keys is the orders. Can you see which 2 fields in the orders table links to the other 2 tables, customers and products? Alright, let's review the answer. So the ones in pink are the primary keys because they uniquely identify the record. So the customer ID C1, C2 and C3 uniquely identifies the record about each customer, their name, their address, maybe their phone number, things like that. Okay. And then your product ID also uniquely identifies the product in the products table. So you have the product name, you have the description, perhaps the cost as well. And in the orders table, the primary key is the order ID because the order ID is unique. Now you notice that in the orders table, I linked to the customers table using the customer ID. So for example, the first order ID 1000, I know that customer C1, okay, whose name is Fred and has whatever address blah blah blah, okay, is buying product P1, okay, and I can refer to the products table to know what P1 is. So P1 is a shirt with some description, okay, and according to the orders table, this person Fred is ordering one shirt. So this is an idea of how the foreign keys can link to other tables to give you more information about what each order is about. At the same time, you may think, why is it so complicated that I need to link to another table? Why can't I just have all the data in the same table, right? So could these three tables be merged into one slide? This is a natural question to ask based on the data. So the answer is yes. In fact, this is what I've done here. I tried to create a orders table, okay, with all the customer names and addresses according to the customer ID, as well as the product names and the description of the product. Okay, so since we know that we can do this, the question then is, why do we put it into three tables? Why do we complicate a simple matter, right? Well, the conclusion or the question of which one is more complicated, three tables or one table, is quite contentious. You may think that three tables is more complicated than one, but I think that one table can make things even more complicated in the future. So imagine what happens when we try to change Fred's address. So if I have all the data in one table like this, how many cells do I need to change if I want to update Fred's address? So as you can count, I have to update 1, 2, 3, 4 cells in order to update Fred's address, and that is going to be very tedious, right? So if I had the data in a separate table, if I had the customer data in a separate table, all I need to do is update one time, and that's it. I don't have to search and replace every single cell that has Fred's address. So in a sense, this reduces redundancy, reduces repetition in our data, which makes it easier for updating, as well as makes things cleaner in order to find a certain data. Okay. Another reason for this, or a related reason for this, is, remember we started off this whole chapter talking about big data, right? And we have so much data being generated in the world nowadays. So if we have so much redundancy in our table, and if it's a table of big data, imagine we have tens of thousands of rows of orders. It's going to take up a lot of space if there's so much redundancy. If let's say Fred orders 500 items, okay, we're going to have his address repeated 500 times. It's going to be very redundant and a waste of space. Storage space is a constraint when it comes to big data. If you have a lot of redundancy, that increases the volume of space, and that means that your data becomes more expensive to store. So we want to get rid of that redundancy as much as possible. So I hope that addresses the question of why we want to use relational databases instead of storing everything into one big table. So now I want to give the idea of what a data model is about. So the data model should keep track. So with more than one table, you may want to keep track of how the tables are linked together. So a data model would give the idea of which table is linked to which table, and which are your foreign keys, which are your primary keys. So you notice in this data model, I have marked out the primary keys with a PK and foreign keys with a FK, and the foreign keys will link to a PK in another table. So this just gives a visual representation of how our data is being stored, where is our data being stored, and what data can I get from which table, or conversely, where should I go if I want to find a certain piece of information. So now you may be wondering, I've talked about relational databases. Is there such a thing as non-relational data? Well, it turns out yes, there is. Okay? Non-relational data just refers to data that is not stored neatly into a group of tables. So non-relational databases is good for data that cannot be neatly captured into tables. For example, sometimes you have addresses from different countries, so they may have different formats. Even within Singapore, some of us live in HDB flats or condominiums. Some of us live in single bungalows, right? Or landed property. A landed property would not have a floor number, but if you live in HDB, you will. So even within Singapore, you already have that variation. Another example of data that cannot be captured neatly into tables is handphone numbers or phone numbers. So some customers may have a home phone, an office phone, and a mobile phone. Some of them may not even have a home phone. So if you have three fields, home, office, and mobile, you may run into the issue of having blank cells, which is not so neat for a relational database. Even if you're able to fill up every field, some people may have more than one mobile phone, and that causes a bit of complication with your data. Some other reasons why we use non-relational databases is for data that was quickly captured and has not been organized into a relational database. So for example, if I just did a survey, I just collected all the results, maybe I just wanted to keep them somewhere before I organize it, or I have not had the time to organize it yet, so I just dump everything all together, okay, and I'll have to sort through it later to make a relational database. There's also some data that cannot be stored in numbers or in strings of characters in a table. Such data, examples of such data is like photos, documents, videos. If you want to turn them into relational databases, you may have to do something about maybe do some pre-processing to count maybe the number of cats in photos, or to document how long each video is, or maybe do some tagging, who are the actors in the video, what genre is it, things like that. But that still does not fully explain what the video is about, right? So all this is considered non-relational data. So just to have a quick recap of what we have talked about so far, we talked about how big data led to the rise of data science. Big data and IoT, all these things have led to the rise of data science. And with data science and big data, there's also a need to organize your data neatly. And our answer to that most of the time is a relational database. So that is the answer to the essential question: how can raw data be organized into databases for efficient analysis? We use a relational database most of the time. Now, let's talk a bit about how, let's do some practice on creating your own relational database. So I have some data here about students in our fictitious Fruit Secondary School, their form teachers, as well as their CCA. So you've been given this file, open it up and analyze the data. First thing you need to find out is which column in this database you think is your primary key, or do you think you want to use as your primary key, so that this primary key, remember, should uniquely identify the record, each record. Next, here are some things that you may want to think about as you prepare to split this data into a relational database. So think about what data is unique, which fields are unique, which data is duplicated, just like the address of the customers we saw in our example. So this duplicated data can be put in separate tables on its own and linked to the main table using a foreign key. So if you do that for all the duplicated data or duplicated fields of data, how many tables do you think you get? Well, if you answered 3, then you're correct. So here's your task now. I want you to turn this database into a relational database with 3 tables. So your students table will contain information about all the students. So you may want to make a copy of the original data first. You will also have a classes table that contains the list of classes and related information. And finally, the CCAs table, which contains a list of CCAs and related information. What is considered the related information is something that you have to find out for yourself. Right? So some good habits in making a relational database. Okay, I want you to ensure that your primary key is the first field in each database. Okay, this makes your primary keys more accessible. And something for your own self to see whether you have understood what a foreign key is. Okay, I would also like you to color your foreign keys in yellow if you have any. Once you have done that, you may take a look at some of these tools that Excel has to help you mark out your databases. So if you go to the insert ribbon, there is a button called table. Okay. Although it says table, actually it's a database table. So it will turn your data into a database table. So when you click that button, when you select your data and click the button, you have a pop-up window like the one at the bottom. It will ask you to confirm that your data is in this range. Select the checkbox of my table has headers. This will so that your data can be so the headers are captured by Excel. Next, you may also want to click on the table design. This table design ribbon will suddenly appear after you create your database table. So click on the table design ribbon and then rename your table, okay, either students or CCAs or classes. Okay. Don't forget to rename your tab too, otherwise especially if you have a relational database with many tables, you will get lost easily finding the table that you want. And that's it. We're done. I hope with the practical you're also able to understand better how this raw data that I have given you can be organized into a relational database for more effective analysis next time. So here are some references or for further reading if you're interested. Thank you for watching. I hope you have learned something new today. Take care, and I'll see you next time.